Greetings, one and all, and welcome to this lesson on vectors. Notice that in this question, they give us two vectors, and these are two column vectors, and these are also position vectors because they start at the origin. Notice OA, right? O start meaning the origin, and they start at the point, this particular vector start at the origin and ends at the point A. And so this vector OA is a column vector because it is written in column, it has a column orientation. It is written in column form. So we have the 4 on top and a -2 at the bottom. And so we have this position vector, or we can also call it a column vector. Position vector because of the way, because its initial point is at the origin, because the initial point is O, and column vector because it's written in form of a column. Let me say it again. OA is a position vector because it starts at O, and is a column vector because it is written in column form. So we also have OB. OB is also a position vector and it's also a column vector. A position vector because it starts at O, it starts at the origin, it starts at the point 0, 0, and it terminates at the point B. So we have the column vector 10, 6. And so the question asks us, hey, we know that OA is 4 and -2, and we know that OB is 10 and 6. So seeing that we know that, then write AB as a column matrix. So how are we going to do this? How are we going to write AB as a column matrix or as a column vector? So let us begin. So here we have AB. So we're considering this particular question BI. So you want to write AB as a column vector or as a column matrix. So AB, but what is AB, right? What is AB? What is the vector AB? So let's put this all in a graph form. So we know that, let's put this all in a graph form. Notice that OA, this is the vector OA. It starts at the origin, right? Its initial point is at the origin, and it goes all the way to A, right? And the point A is 4, -2. So this is the vector OA. This is the vector OA right here. Now OB, the vector OB is here. So because we have 10 and 6, and notice 10 and 6. And so the vector OB is here, and the vector OA is here. Now, where's the vector AB? Well, the vector AB would be represented by this red line because we start at A and we end in at B. Okay, so this is the vector AB. So using this diagram, let us see how we can start at A and then go to B. How are we going to do it? There's two ways. We can go straight directly to B, but let's not use that route. Let's go the other way around. So if we start at A and if we start at A and trying to get to B, well, we'll need to start at A and then go to O, right? Then when we get from O, we get from O to B. So let's remember that. We start at A and then we go to O. So let us make that known here. So AB is going to be equal to, remember, we're going to start at where? A, then we're going to go where? Start at A, and then we're going to go to O. Just like how we represented here in this diagram. Start at A, and then go to O. And after you reach to O, then we're going to start again at O, and then go to B, so OB. And so let's represent that. It's going to be plus OB. All right, okay? So now, what is AO, right? What is the vector AO? Well, the vector AO, another way we can write the vector AO is AO, the vector AO is the same thing as negative OA. Vector AO is the same thing as negative OA. You say, how? Well, if we have any vector, say we have the vector a, b, right? AB, the vector AB is always going to be equal to the vector negative BA. Okay, so that's a formula you can remember. So if we have the vector AB, AB is also equal to negative BA. Okay, so AO equals negative OA. There's another explanation that we can use to explain this. And so let's consider that. Notice, right? Notice that if I tell you to write, if I tell you write OA, right? Like draw OA. Well, if you were to draw OA, you're going to draw OA. Draw OA. If you were to draw OA for me, you would start at, you would draw it like this, and you would start at O and end at A. And that is indeed OA. Okay. And now what if I tell you, draw for me AO, right? Draw for me AO. But if you were to draw for me AO, then again, you would draw the same vector almost. What you'll do is you'll again start at, sorry, what you'll do is you'll draw almost the same vector, right? The vectors would indeed have the same size, but you would say, Isaac, I'm starting at A, so I'm going to start at A, right? And I'm going to end at O. So, your diagram of AO would be the same thing as your diagram or your vector for OA. The only thing is that it's heading in a different direction. So they're the same vector, just heading in opposite directions. But what if I ask you to tell me what negative OA is? What is negative OA? Well, we know OA is heading downwards. So negative OA would be heading where? Upwards. It's the same vector, basically, but it's just heading in the opposite direction. And so we'll have OA. Now, hopefully now you can see clearly that, look, the vector OA, right, is the same thing as the vector negative OA. Because look, this is the same thing as this. Because look, they're heading in the same direction and they have the same magnitude. And so that's why we say OAO is equal to negative OA. So AO equals negative OA. So we're going to add, now we're going to add OB. Add OB. Okay, so let us simplify. So what is OA based on the information they give us on the top? Well, based on the information that they give us on the top, OA is equal to 4 and negative 2. So it's going to be negative, because we have a negative out front. And it's going to be open bracket 4 and negative 2 plus OB. What is OB? OB is 10 and 6. Now let's simplify some more. What is negative 1? Now you can look at this as having an invisible 1 out front. What is negative 1 times 4? Well, negative 1 times 4 is going to be equal to negative 4. Negative 1 times 4 is equal to negative 4. What is negative 1 times negative 2? Now, negative 1 times negative 2 is positive 2 plus, in bracket, we bring down the 10 and we bring down the 6. We write the same thing down. So 10 and 6. So now what is negative 4 plus 10? What is negative 4 plus 10? So if you owe me $4 and you have $10 and you pay me back the $4 that you owe me, how much do you have left? Well, you should have $6 left. So negative 4 plus 10 is 6. Now what is 2 plus 6? Well, 2 plus 6 is indeed 8. So AB, written as a column matrix or as a column vector, is actually equal to AB, written as a column vector, is actually equal to 6, 8. 6, 8. Okay, awesome. Now they want us, seeing that we have calculated the AB as a column matrix, now they want us to calculate the magnitude of AB. And so all they're saying is, in order to calculate the magnitude, all that you do is you take the top entry and you square it. So we're going to square 6. And you take the bottom entry, 8, and square it. So we're going to square 8. And then you perform the square root. So what does that all mean? Let us consider that in blue. So we're trying to figure out the magnitude of AB. The magnitude of AB. And so the magnitude of AB is going to be equal to, we're going to take the 6 here and we're going to square it. And 6 squared is actually the same thing as 6 times 6. And that's what we mean when we say 6 squared. So 6 squared is 6 times 6 plus, we're going to add, we're going to take the 8 and square it as well. So it's going to be 8 squared. And then we perform the square root. Okay, and that's how we find the magnitude. In order to find the magnitude, you must take the first number, square it, take the second number, and you must take, in order to perform the magnitude, you must take the first number, 6, square it, take the second number, 8, square it, add the 2, and then perform the square root operation. Okay, so what is 6 times 6? What is 6 times 6? Well, 6 times 6 is indeed 36. That means that 6 squared is 36. So 36. Now let's write that better than that. So again, 6 times 6 is 36. Plus, what is 8 times 8? 8 times 8 is indeed 64. 64. 8 times 8 is 64. So we put the 64 right here below. And then we keep the square root sign. Now what is 64 plus 36? Let's add them. 64 plus 36. What is 4? What is 6 plus 4? 6 plus 4 is 10. So we put the 0 down and we put the 1 above. Now 6 plus 1 is 7. Plus 3 is going to be 10. So it's going to be equal to 36 plus 64 is actually equal to 100. 100. And so, what is the square root of 100? Basically, what number, when you multiply it by itself, is going to give you 100? No, it is not 50, because 50 times 50 is not 100. What number times itself is going to give you 100? The answer is 10, because 10 times 10 is 100. And so there we have it. We have the magnitude of AB, which is equal to 10, right? That's correct. And we have AB written as a column matrix. So this is your answer for these two questions. Hopefully you find that helpful. Thank you for watching, and I'll see you in the next video.